Hi, this is Sophia. Today, I'm going to present on our group's design concept called Sound Lab. In today's fast-paced life, most people often have various kinds of stress or having varying degrees of anxiety. These pressures may come from school, work, or family and have a bad influence on their mood and even affect their mental health. Through the research, it can be found that the music can be regarded as a better way to relieve stress, and most people would prefer to listen to daily sound to keep calm. According to this, the problem space studied by our team is to use daily sound to help people reduce stress, ease tension, and keep calm. We will show you the expected effect of our project. The project can be seen as a sound processing device, which is composed of 5 parts, namely dropper, test tube, jar, beaker, and trash can. The dropper is a sound collection device. The user can place the dropper close to their interested sound source and record the sound by squeezing the head of the dropper. When the dropper starts to work, the built-in LED will turn on. The test tube is a device used to store the collected sound. Users can use the dropper to collect a variety of sounds they like and store these sounds in different test tubes. After selecting an empty test tube, users can use the dropper to touch the inner wall of the test tube to complete the sound storage. When sound is stored in the test tube, the light in the test tube will light up. If the user forgets the sound stored in the test tube, he can play back the sound by shaking the test tube. Unlike the storage contents of test tubes, the jars store fixed melody that cannot be changed. These melodies are music fragments that can help people relieve stress, such as piano music and violin music. These melodies can help users who have no music foundation to create more harmonious music. Users can listen to the melody by shaking the jar. Let me show you how to do the sound mixing. First, select the main melody stored in the jar and select the daily sound stored in the test tube that you would like to mix together with. And then pour into the beaker in sequence. Each time a sound clip is mixed into the beaker, an additional light will illuminate in the beaker. The user can mix the music by shaking the beaker, and the mixed sound will be played while shaking. The trash can is used to delete sounds. The user can delete the mixed sound by dumping the beaker above the trash can. The lights in the beaker will also turn off. The target audience of our project consists of 2 parts. The first one is those non-professionals who are interested in creating music. The another one is those who want to relieve stress through music. Next, I would like to briefly introduce to you to the current progress of our project. As you can see, this showing picture is the overall rendering of the current project. At present, through the efforts of our team members, we have completed the realization of the main functions, including the connection of the Arduino and the writing of the background code. That is, the device can already be used for simple sound recording, playing, mixing, and deleting functions. In addition, some simple visual effects are also designed. Our team members will detail their personal contributions in their respective videos. As for my contribution, I'm mainly responsible for the design and implementation of the sound storage, playback, and deletion function. That is, the test tube part of our project. This function can be regarded as a link to other functions, and it plays a role of transition in the realization of the overall team project. The components of the test tube consist of 3 main parts. 1 press sensor, 1 tilt-ball switch, and 1 LED light. The achieved effects might be: when the sound collecting dropper touches the inner wall of the test tube, the sound stored in the dropper will be transferred to the test tube. The LED light will be on when there is sound storage in the test tube. When shaking the test tube, the stored sound would be played back. When the test tube is picked up and pulled into the beaker, the sound in the test tube will be transferred to the beaker, and the LED light will be dimmed to indicate that the test tube is empty. The test tube in the beaker corresponding to the test tube will light to indicate that the sound has been transferred. Now let me show you how it works. When someone wants to record a certain sound of his favorite, he can take off the dropper and move the dropper closer to the sound and squeeze. The LED will be on. After the sound recording is completed, the user can transfer the sound. He can pick up the test tube and use a dropper to touch the inner wall of the test tube, and the sound will be successfully transferred. The LED inside the test tube will indicate whether there is sound inside. If the user forgets what sound is stored, they can play it back by shaking the test tube. The sound can be transferred to the beaker by dumping. When the sound is transferred, the LED in the test tube will go out to indicate that the test tube is empty. Let me show you how it works through codes. I gave my Arduino code and Python code for my part here. In Arduino part, in simple terms, different effects are triggered by different readings of different signals. For example, the 12th switch is a digital signal. It only has two states, 0 and 1. The effect of the partial dumping of the test tube is a different effect triggered by controlling different reading of the tail switch. Similarly, although the pressure sensor is an analog signal, it means that it can read out the specific pressure value, which can be triggered by coding to limit different effects, and the sound transmission is carried out by limiting the value. Now turning to the Python part. Due to the limited memory of the Arduino development board, it cannot support the storage and recall of the audio. We connect Python and the Arduino and use the computer as an additional storage terminal for the audio storage. There are still many areas for improvement of this prototype. In the following project process, we try to keep the project as tidy as possible. For example, think of some ways to make the wires look less messy, as well as improving the unimplemented interactive function and make it a fully functioning product. Thanks for watching.